The images projected onto the screen from the projector are formed from the projection source using a reflective technology called digital light processing, DLP. The DLP processing board uses a digital micromirror device, or DMD, which acts as a light switch. Inside each DMD chip are many tiny mirrors which correspond to 1 pixel of light in the projected image. The tiny mirrors tilt towards or away from the light source thousands of times a second to produce up to 1,024 shades of gray. In a single chip DLP system, a color wheel is added to convert the monochrome picture into color. When the color wheel spins, it causes red, green, and blue light to fall sequentially onto the DMD chip. When on and off states of these tiny mirrors are coordinated with these flashes of light, over 1 billion colors can be created. In a 3-chip DLP system, white light is passed through a prism that divides the light into red, green, and blue. Each chip is dedicated to a primary color. The red, green, and blue reflections from the 3 chips are combined and passed through the lens to project an image made up of more than 35 trillion colors. As opposed to DLP technology, where light is reflected from digital micromirror devices, DMDs, or chips, LCD technology passes light through the polysilicon LCD panel and is therefore known as a transmissive technology. A liquid crystal display basically comprises of 2 transparent sheets of a polarizing material, with liquid containing rod-shaped crystals sandwiched between them. The LCD panels themselves do not emit light, but are backlit with red, green, and blue light. Light is lost when polarized light hits the edges of the transistors. The light does not pass through and a grid-type shadow is created. For this reason, many of Christie's LCD projectors are equipped with a micro-lens array, enabling a greater concentration of light onto the panel and reducing light lost after it passes through the panel. Where the DLP chip is made up of millions of tiny mirrors, the LCD chip is made up of millions of tiny cells. Each cell's opacity can be controlled by sending an electrical signal that controls the light transmission properties of the LCD panel. Light is polarized before it passes through the LCD. An electrical charge is applied to the crystals in the layer, causing them to rotate the plane of polarized light. These on and off states can produce up to 256 shades of gray, or 8-bit processing. In a 3-chip LCD system, white light is passed through a series of dichroic mirrors that divide the light into red, green, and blue. Each chip is dedicated to a primary color. The red, green, and blue images from the chips are combined and passed through the lens to project the image. Although transmissive technology does not replicate the image quality of reflective technology, such as DLP systems, Christie considers that high-quality LCD technology has advanced to sufficient standard to be offered to its customers as a lower-cost alternative.